Hey, and welcome to Exponential and Logarithmic Functions Review. In this lesson, we'll just be reviewing exponential functions and logarithmic functions and what we've learned about them so far. This is the content found in Chapter 7 of your online textbook. So we'll review that for the upcoming chapter test. We first talked about exponential equations and using those exponential equations to model certain real-life events. The first one was exponential growth. We talked about rates, and we talked about principal amounts, and we talked about things increasing exponentially over time. For example, populations increasing at a certain rate over a certain amount of years. We also talked about interest and bank accounts. So this example is exponential growth. It's the formula or the model we use for exponential growth, with R being the rate. You want to use that as a decimal. So if it's in percent, you want to change that percent into a decimal. For example, we could say if I had $2,000 and I put it into a bank account and it increased 7% every year, after how many years will it reach a certain amount, or will it reach a certain amount, or when it reaches a certain amount, how long does it take to get to that amount? We also talked about exponential decay. When you start with an amount, and instead of it increasing exponentially over time, it decreases exponentially over time. One of the examples used for exponential decay was the depreciation of the value of a car. Depreciation just means that the value goes down over a certain amount of time of using a car. So if we bought a car for $30,000, that would be our principal amount. And if it decreased, if the value decreased at a certain rate every year, after a certain amount of years, we could figure out what the value of the car was. Or we could figure out maybe how long it would take for the value of a car to reach a certain amount. After we talked about exponential equations, we introduced logarithmic equations. Here are some properties of rewriting logarithms. We first talked about log base a of m times n is the same as log base a m plus log base a n. We talked about log base a m divided by n is the same as log base a m minus log base a n. We also talked about log base a n to the k is the same as k times log base a of n, and log base a times the square root of n, or the k root, sorry, of n equals 1 over k log base a n. We also discussed and reviewed the properties of exponents as well, and compared them to the logarithmic property. We saw that the properties of exponential equations and logarithmic equations are similar because they are in fact inverse equations. So if I had, for example, 2 to the x, the inverse of that would be log base 2. So we can use logs and exponents to solve problems by using the inverse to cancel out and find x. So if I had y equals log base a of x, I could rewrite that as x equals a to the y. What I'm doing here is I'm raising both sides of the equation to a, or by the base a, so a to the y, and then a to the log base a of x. Since the bases are the same for the exponent and the log, they divide to 1, and therefore x will be left on the right side, and you have x equals a to the y. Here's another way of thinking about how to rewrite equations from exponential form to logarithmic form. You just want to take the y and put it into the log. The bases stay the same, so b is the base for the exponent, b will be the base for the log, and so x equals log base b of y. And then we talked about the natural log, which is log base e of x, And we talked about how the inverse for the natural log is e to the x. And here are those two graphs. Again, log base e of x is written as the natural log, or ln of x. And e is a transcendental number that is commonly encountered when working with exponential models. So e is used as a base in many models to describe exponential growth or even exponential decay. So that was our review of exponential functions and logarithmic functions. Go ahead and try the homework assignment for this review to help you prepare for the test. If you have any questions about any content covered in this chapter before you take the test, please reach out to me. I want to make sure you understand everything so you can give your test your best attempt. Welcome to this lesson on inverse variation.